Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we will be continuing looking at straight lines and in particular in this lesson, gradients. We will expand from what we learned the last time on gradients, saying that is equal to the vertical distance divided by the horizontal distance between 2 points. And we will also go into more detail on how we can calculate the gradient of a straight line. We will also address what is a positive gradient and what is a negative gradient. And then finally we will look at what is known as the gradient equation so that we can calculate the gradient of any straight line with ease. So let's get started.
Ooh la la!
So in the first lesson we learned that the general equation of a straight line can be represented as y is equal to mx plus c, and we said that m represents the gradient or the slope of the line, and c represents the y-intercept or the point on which the line crosses the y-axis. Now in this lesson we're going to go into a little bit more detail on this general equation so that we can understand it a little bit better and also have a few examples where we can solve problems using the general equation. So one thing that we can say about the gradient now is that it's equal to the vertical distance divided by the horizontal distance between 2 points on the line. So for example, let's say we have this blue line here and we want to calculate the gradient of it. So what we have to do is calculate the vertical distance and the horizontal distance between 2 points on this line. We already have one point right here, which is the point 6, 4, and we can see that it also passes through the origin here, so that means that we can use this second point of 0, 0. And then so the vertical distance between the 2 points is the distance up and down, so we can see here that point starts here 0, 0 and 6, 4 comes up to here, and the distance up and down we can see is 4, so we can see the vertical distance is 4, and then the horizontal distance is the distance left to right, and we can see here between this point and this point the horizontal distance is 6, so we can write that in as well. So if our gradient is equal to 4 divided by 6, we can then say that m would be equal to 2 over 3, because that's just a simplified version of 4 over 6, and if we wanted to write this out in a decimal form, this would be equal to 0.66666. If you put that in your calculator, it would keep going on, but we are going to just simplify it to 2 decimal places, and we can say the gradient is equal to 0.67. So once again, the gradient is equal to the vertical distance divided by the horizontal distance between 2 points. But let's have a look at this example where we don't have a point that goes through the origin. This time we have a point 2, 0 and the point 8, 8. But one thing I want to emphasise before we do this question is that if we have a line and we want to choose 2 points on that line to calculate the gradient, it doesn't matter where the points lie on the line, you should always get the same gradient. So that would mean that, say we had a point here as well on the line, or maybe one up here as well, regardless of which 2 points that we use to calculate the vertical distance and the horizontal distance between, we should always get the same gradient, because that's the thing about straight lines. There's no curves or there's no bends, the line just follows a straight path, and that would mean that the entire length of the line has the same gradient. So it doesn't matter which 2 points that we choose, as long as we do it correctly of course, and then we can calculate the vertical distance and the horizontal distance between them. So first of all we have to calculate the vertical distance between these 2 points, and that is a distance up and down. Well, we can see that this point still lies on the x-axis and this one comes up to 8 on the y, so we can see that the vertical distance or the distance up and down is also 8. And then for the horizontal distance, this time we can see this point comes out to 2 on the x-axis and this one comes along to 8, so that means that the horizontal distance is going to be 8 minus 2, because that's the distance between this point and this point. So if our gradient is equal to 8 divided by 8 minus 2, we can also say that is equal to 8 divided by 6, because 8 minus 2 is just 6. And then finally, if we wanted to calculate 8 divided by 6, well, we could simplify this first of all by saying that is equal to 4 divided by 3, or if we wanted to write this out in decimal form, we would have 1.33333, But to simplify again, we're just going to have 2 decimal points and write the gradient is equal to 1.33. And again, if you're unsure about these little sums just now, you can just do this in your calculator. So if you get to this stage and you get that the gradient is equal to 8 divided by 6, then you can just put this into your calculator and you'll get this same answer of 1.33. Okay, so far the examples have had a line where it's been sloping up the way like this. So it starts at the bottom, or down here to the left, and it rises as it travels right. But what if I said that if we wanted to calculate a line which slopes in the other direction, so it starts at the top and it goes down to the bottom, so we can see that it's dropping? Well, the rule that we have with gradients is if the line is sloping up the way from left to right, as we can see, we can imagine that we're almost travelling up a hill, so it's going positive. But if the line is sloping like this, if it's going down the way, then this would be a negative gradient. So if the line's sloping up, it's positive, and if it's going down, it's negative. So let's imagine we have this line here, and we're asked to calculate the gradient of it. And we've been told on this line we have the points 0, 6 and the points 3, 0. Now the first thing that we can do is calculate the vertical and horizontal distances between these 2 points. So for the first point 0, 6, because it lies on the y-axis, we can see that it comes up a distance of 6. And for the point 3, 0, it's on the x-axis, so that means that the y is 0 but it comes along the x-axis at 3. So that would mean that the vertical distance, or the distance up and down, would be 6, and the horizontal distance would be 3. But because it's now a negative line, because it's sloping up to down, then we have to put a negative sign in front of it as well, so that we take the direction of the slope into account. So then if our gradient is equal to minus 6 divided by 3, well, we can say that 6 divided by 3 is 2, so that would mean that our gradient is equal to minus 2. So just remember, when we go to solve these problems or we have to calculate a gradient, you have to check which direction the line is sloping. So again, if it's sloping like this one, up to down, if it's going down the way, then it's negative, but if it's going up the way, it's positive. Okay, so this next example, we have a line here and we're asked to find the gradient, and the points we are given are 0, 4 and 10, 4. So if we want to find the gradient, we have to find what is the vertical distance and what is the horizontal distance. Well, the first thing to notice is that both of these points have the same y coordinate within them. They both have 0, 4 and 10, 4. They both are in line with this point 4 on the y-axis. And because that's the case, that means that the line is perfectly straight with the x-axis, or we can say that it's parallel to the x-axis. And because that's the case, we can say that the vertical distance, or the distance up and down between these 2 points, are 0 because they lie directly across from one another. So we can say that m is equal to 0 divided by the horizontal distance. Well, we know that comes across to 10. And if we have 0 divided by anything, the answer would just be 0. So if we have a line that is parallel with the x-axis, just like this one is here, then the gradient is always 0. So now what if we want to calculate the gradient of a line like this? Well, again, we can do the same process of calculating the vertical distance and the horizontal distance between 2 points. So we can say that the vertical distance, so we have the point here which comes along 10 at the y-axis, and we have here on the x-axis that lies at 0. So the vertical distance is the distance between here and here, which we can say is 10. Well, the horizontal distance would be the distance left to right, but we can see this time they lie perfectly straight with one another, and the line this time we can say is parallel to the y-axis. So if it's this the case, the line is also vertical, straight up and down, then the horizontal distance would be 0. So what would the gradient be? Well, one thing in maths is if we ever divide anything by 0, we have some form of error, because it's not mathematically possible to divide anything by 0, so that would mean that the gradient can just be called undefined. So if we have a line like this one, where it's parallel with the y-axis or running vertical, then the gradient is just undefined, it does not exist. So just to recap that little bit on gradients, we said that if the line is going up the way like this, then it's a positive gradient. If it's sloping down the way, it's negative, and that means we have to add a negative sign on when we are calculating the vertical and horizontal distances. If the line is parallel with the x-axis or running left to right like this, then the gradient is 0. And if it's parallel with the y-axis or running up and down vertically straight, then the gradient is undefined. So if you think it's easy to remember that this is positive, this is negative, and this is 0 for instance, then stick with the way that I've just showed you. But I'm also going to show you an equation where we don't have to remember which is positive, which is negative, and so on, and we will get the correct answer regardless. So I'm going to do this by showing an example. Here we have a line, and we have the points on the line 0, 1 and 10, 3. And to begin this method, what we're going to do is label one point, point 1, and label the other point, point 2. It doesn't matter which point, just as long as we can identify which is point 1 and which is point 2. And now once we've done that, I'm going to write out each of the coordinates. So we have 0, 1 and 10, 3. And we know that for each of the coordinates, the first number represents the x value and the second represents the y. And because we've now labelled each of these 1 and 2, what I'm going to say is, for point 1, that this number represents x1 and this represents y1. And for point 2, this represents x2 and this represents y2. So that's just the x and y coordinates for point 1 and point 2. And now we know what x1, y1, x2 and y2 are, we can now say an equation for the gradient of any line is equal to y2 minus y1 all over or divided by x2 minus x1. And if you think about it, this equation is basically the same as this, because on the top here we have the vertical distance, and that's represented by subtracting both the y distances from each other, which represents the vertical distance, and also the x's take away each other, so the difference between the x's represents the horizontal distance. But if we write it in this form and we label each of the coordinates of x1, y1, x2 and y2, then we can use this to find the gradient without having to worry which direction is positive or which is negative. So now we're going to use this formula to calculate the gradient of this line. So we can write that m is equal to y2, so y2 in this case is equal to 3, minus y1, and we see here y1 is equal to 1, divided by x2, which is 10, take away x1, which is 0. So if we do the sums on the top and the bottom, we can see that 3 minus 1 is equal to 2, and 10 minus 0 is equal to 10. Now if we wanted to simplify this, we could write it as 1 divided by 5, and that would also be equal to, in a decimal form, would be equal to 0.2. Okay, so we're going to do one more example using this new equation that we have, and this time it's going to be a little bit trickier to find the gradient, but one thing I want you to be careful of is the signs, in particular the negative signs when we use it in this equation. So we want to find the gradient of this line using these 2 points, minus 2, 9, and 4, minus 3. If you'd like to give this a try yourself, just pause the video just now, and then I'll go over the answer when you've finished. So the first step that I'm going to do is label point 1 and point 2. So I'm just going to label this one point 1, and then this one point 2. And now we've done that, I'm now going to label each part of the coordinate its x and y counterpart. So that means that because this is point 1, this is going to be x1 and y1, and then point 2, we're going to have x2 and y2. So that's just saying that minus 2 is x1, 9 is y1, 4 is x2, and minus 3 is y2. So our next job is to put these values into our equation. So our equation is m is equal to y2 minus y1 divided by x2 minus x1. So from our equation, we know that y2 is equal to minus 3, and that's take away y1, which is 9. So on the top we have minus 3 minus 9, and then we have x2, which is 4, minus x1. Now notice here that x1 is equal to minus 2, So we want to say that the bottom part is going to be 4 minus 2. So don't forget to put that in there. So on the top we have minus 3 minus 9, which would be equal to minus 12. And then on the bottom, because it's 4 minus 2, that's going to be equal to 4 plus 2, because two minus signs together become a positive. So if that's the case, we then have minus 12 divided by 4 plus 2, which is equal to 6. And then if we want to divide minus 12 by 6, well, we know that 12 divided by 6 is equal to 2. So that means that m would be equal to minus 2. And as you can see that if we do this sum correctly using this equation, that it works out in the end we already have the negative sign in the gradient, and we know that's correct because the line itself is sloping down the way, which means that we're going to have a negative gradient. So let's recap this lesson on straight lines and in particular gradients. So we said that the gradient can be generally defined as being equal to the vertical distance divided by the horizontal distance between 2 points. And we now know that if the gradient is sloping up the way, then the answer of this is going to be positive. If it's sloping down the way, then the answer of this is going to be negative. If the line is horizontal or it runs parallel with the x-axis, then it's 0. But if the line is vertical or it's parallel with the y-axis, then the gradient is undefined. And we now know that if we have 2 points and we can write them in the form x1, y1 and x2, y2, we can express the gradient in the form of y2 minus y1 divided by x2 minus x1. And using this calculation, we don't have to worry about if the gradient is positive or negative, but it is always good to remember these just so that we can check the answer to this in the end to see that if it makes sense and is correct. So I hope this National 4 Maths lesson on gradients and straight lines has been helpful to you, and if that's been the case, we would appreciate liking this video. And if you'd like to see more content like this, you should subscribe to our channel or head to our website at penguin-learning.com. And as always, if you have any questions on this video, be sure to drop them down below and I'll get back to you as soon as possible. Thanks again for watching, and I'll see you in the next video.